Hey there, builders and makers. Today we're diving into the exciting world of sheet metal in SolidWorks. Sheet metal is all around us, from car bodies to kitchen appliances. SolidWorks provides us with powerful tools to design and bring those sheet metal creations to life even before we step foot in the workshop. These tools help us create three-dimensional models of our designs, complete with bends, flanges, and cutouts. This digital prototyping saves time, material, and reduces the chance of costly errors during the actual fabrication process. Think of it like this. Instead of bending actual metal sheets and hoping for the best, we can now fine-tune our designs digitally. Once we're happy with the virtual prototype, SolidWorks can generate detailed drawings and instructions for manufacturing. This seamless transition from design to production is what makes sheet metal tools in SolidWorks so invaluable. Alright, let's get our hands dirty and create our first sheet metal part in SolidWorks. Don't worry, it's easier than you might think. First, we'll start a new part file and select the sheet metal template. This template sets up the environment with the right tools and settings for sheet metal design. Next, we need to define our base flange. This is the starting point of our sheet metal part, like the foundation of a house. We can sketch a simple rectangle or any other shape we need. SolidWorks will ask for the sheet metal thickness. With the base flange defined, we're ready to start adding bends and features. SolidWorks offers a range of intuitive tools to manipulate our sheet metal part. If we change the size of our base flange, all the subsequent features will update automatically. This dynamic relationship between features makes designing in SolidWorks incredibly efficient and powerful. The Edge Flange tool is our go-to for creating those classic sheet metal bends. Select the edge we want to bend, specify the angle and direction of the bend, and voila! SolidWorks creates a clean, precise flange along the selected edge. The Edge Flange tool offers several customization options. We can control the flange length, relief cuts at the corners, and even add bends to curved edges. This flexibility allows us to create a wide variety of shapes and forms, from simple boxes to complex enclosures. One of the neat features of the Edge Flange tool is the ability to create unfold features. This flat pattern is essential for manufacturing as it shows the exact shape and dimensions needed to cut and bend the sheet metal. The more comfortable we get with this fundamental tool, the more confident we'll be in tackling complex sheet metal designs. Now that we've got the hang of the Edge Flange tool, let's explore some other essential sheet metal tools in SolidWorks. The Miter Flange tool allows us to create angled bends, perfect for joining two sheet metal parts at a corner. Next up is the Hem tool, which adds strength and a professional touch to our sheet metal parts. The Jog tool is perfect for creating those stepped bends, often used for mounting brackets or adding reinforcement. Finally, we have the Sketched Bend tool, which gives us ultimate control over bend shapes. With this tool, we can sketch any profile we want, and SolidWorks will bend the sheet metal accordingly. This is incredibly powerful for creating complex curves and contours. Section 5. Unfolding the magic generating flat patterns for fabrication. Once we've designed our sheet metal masterpiece in SolidWorks, it's time to unfold the magic and generate a flat pattern. To unfold our part, we simply click the Flatten command, and SolidWorks does the rest. The flat pattern shows us the exact shape, dimensions, and bend lines needed to fabricate the part. SolidWorks allows us to customize the flat pattern, adding bend allowances, punch locations, and other manufacturing information. We can even export the flat pattern in various formats, making it easy to share with our manufacturing partners. The ability to generate accurate flat patterns is a game changer for sheet metal design. Section 6. The nitty-gritty understanding key sheet metal parameters. While designing sheet metal parts in SolidWorks is incredibly intuitive, understanding a few key parameters can significantly enhance our designs and ensure manufacturability. These parameters control how our sheet metal bends, stretches, and ultimately takes shape. First up is the thickness parameter. This one's pretty straightforward. It defines the thickness of our sheet metal. SolidWorks uses this value to calculate bend allowances and ensure that our parts fit together correctly. Next, we have the bend radius. This parameter determines the sharpness of our bends. A smaller bend radius results in a tighter bend, while a larger radius creates a gentler curve. Finally, we have the K factor, representing how much the sheet metal stretches during bending. By understanding how these parameters affect our designs, We can create parts that are not only functional but also manufacturable to a high degree of precision. Section 7. From Screen to Reality. Building a sheet metal box in SolidWorks. Let's put our newfound sheet metal knowledge to the test and build a simple box in SolidWorks. This practical example will walk us through the entire process, from creating the base flange to unfolding the final flat pattern. Start by creating a new sheet metal part file and defining the base flange. Sketch a rectangle with the desired dimensions for your box's bottom. Use the Edge Flange tool to create walls for your box. Select each edge of the base flange and specify the desired height for your box walls. Add flanges to the top edges of the walls using the Edge Flange tool again. Create a separate sheet metal part for the lid. Sketch a rectangle slightly larger than the box's opening to allow for the lid to fit snugly. Use the Edge Flange tool to create flanges on the lid that will interlock with the flanges on the box. Finally, use the Flatten command to generate the flat patterns for both the box and the lid. Section 8. Designing for Success. Best Practices for Sheet Metal Mastery. Congratulations, you've made it. We've covered a lot of ground in this sheet metal journey. As we conclude, let's recap some best practices to keep in mind for designing efficient and manufacturable sheet metal parts. First and foremost, always design with manufacturing in mind. Consider the tools and processes that will be used to fabricate your parts. Avoid overly complex geometries and tight bends that might be challenging to achieve. Keep your bend radii consistent whenever possible. This simplifies the manufacturing process and reduces the risk of errors or distortions. Pay attention to material thickness and type. Different materials have different bending characteristics. Use relief cuts strategically, especially at corners where multiple bends intersect. Embrace the iterative design process, learn from your mistakes, and never stop pushing the boundaries of what's possible with sheet metal.